Welcome back to another explainer. Look, today we're unpacking some seriously fascinating insights into how young minds actually process foundational math. Now, if you picture a traditional early ed classroom, you're probably imagining quiet rows of kids just staring at a chalkboard, trying to memorize abstract equations by rote. Well, go ahead and toss that image right out the window. The latest approaches, they are fundamentally changing the game. They're transforming those rigid, notoriously frustrating lessons into a highly engaging, truly interactive experience that maps directly onto how a child's brain naturally wants to learn.
Let me ask you right now, take a quick second and just look around the room you're sitting in. Seriously, look at the sharp corners of your desk, maybe the structured grid of your calendar on the wall, or the angles of your window frame. It is so easy for us adults to forget, but if we tap back into that childlike wonder, we start noticing that math is hidden in plain sight. It is absolutely everywhere. We live in a geometric, quantitative world, and helping kids unlock that exact perspective, turning their everyday environment into this giant playground of numbers and shapes, is exactly the framework we're exploring in this explainer today.
Section 1. Building early math foundations. We're taking abstract concepts and bringing them into tangible reality.
Okay, let's dive into this. Section 2. Arithmetic. Adding and subtracting. The numbers game.
When we define addition simply as the practical action of combining groups together, and subtraction as removing items, we do something incredible for a young learner's developing brain. We're taking these abstract, kind of arbitrary symbols, like a plus or a minus sign, and we're transforming them into physical, tactile actions. The source materials really emphasize that children learn largely through sensory engagement and movement. Think about it. When they are physically combining a pile of 3 apples with a pile of 2, or actually pulling one wooden block away from a tower, they aren't just memorizing a math fact. No way. They are building a fundamental, unbreakable cognitive bridge between a real-world action and a numerical concept. That physical, hands-on engagement, that is exactly what makes the light bulb finally go off in their heads.
And you know, the scale of this early learning might actually surprise you, because kids aren't just sticking to single digits and counting on 2 hands anymore. They are mastering these numerical operations with numbers all the way up to 100. I mean, that represents a massive, super impressive conceptual leap. Going from single digits up to that triple-digit threshold means a child is shifting from simply reciting a memorized list of numbers to actually understanding the deeper, systemic logic of mathematics. It's a huge milestone in their cognitive development. It proves they're really grasping how numbers scale and relate to one another in this ever-expanding systematic universe.
So, how exactly do they manage that leap? Well, the crucial point comes down to understanding place value. To truly conceptualize numbers all the way up to 100, the educational materials highlight the absolute necessity of breaking these daunting figures down into digestible, bite-sized blocks. We're talking about the base 10 system here, grouping by tens and counting by ones. Instead of trying to memorize what feels like an infinite timeline of numbers, a child learns that a number like 34 isn't just a random spot on a chart. Right? It is simply 3 neat groups of 10 blocks plus 4 little individual blocks left over. This highly structured approach totally demystifies the counting process. It builds an incredibly solid mathematical foundation, giving children the conceptual tools they need to decode literally any number they encounter without feeling overwhelmed by its size.
Shifting gears now to Section 3, discovering 2D shapes everywhere. Let's look at the shape of the world.
The source material captures this next cognitive shift perfectly with this quote: "Math isn't just about numbers, it's also about shapes." And I absolutely love that because this marks a dynamic, incredibly fun transition in early learning. Once kids begin to master the basics of counting and arithmetic, we get to completely open their eyes to the geometry that exists all around them every single day. Shapes are truly a child's very first step into the much wider world of spatial awareness. Teaching them about shapes helps them categorize the massive amount of visual data they are constantly absorbing, allowing them to instantly recognize patterns, structures, and boundaries right in their immediate environment.
Now, what's really interesting about this slide is how these rigid mathematical traits map so beautifully to everyday reality. A perfectly round circle isn't just a flat drawing in a textbook. It's the pizza they argue over at dinner, or the clock ticking on the classroom wall. A square, defined by its 4 equal sides, is the checkerboard they play on, or the window they look out of during a car ride. And a triangle with its 3 straight sides is a juicy slice of watermelon, or maybe the yield sign they'll inevitably ignore when they start driving at 16. By teaching the defining mathematical trait and immediately connecting it to something they physically interact with, like their breakfast or their walk to the park, we anchor these abstract concepts in a world they already know, understand, and honestly, love.
And that brings us to Section 4, Real-World Interactive Learning. Let's start putting this math into action.
Let's look at how all these foundational pieces, the adding, the subtracting, and the place value truly come together in a perfect synthesis of learning. A prime example from the resources is the Play Restaurant. Now, this isn't just some cute game to pass the time. It is a highly sophisticated, hands-on learning environment that actively engages multiple areas of executive function. Just imagine a scenario where kids have set up a pretend cafe. They've got menus, they have stacks of play money, and they have designated social roles like chef, waiter, and customer. In this dynamic setting, children are actively using addition when they combine groups of orders, say 2 burgers and 3 milks. They naturally use subtraction when a customer decides to remove an item from their order or when ingredients run out. And they are practicing complex place value up to 100 when they calculate the pretend bill and figure out the change. The absolute genius of this approach is that it wraps complex cognitive tasks in a highly engaging, relatable package. The source material points out that imaginative role-play dramatically increases a child's numerical confidence. Because they're so deeply focused on the social and creative aspects of running a restaurant, the mathematical operations become a natural, integrated tool rather than some stressful academic test. They aren't just learning math, they are living it. And that cements the knowledge far better than any worksheet ever could.
And this brilliantly illustrates how this same immersive, interactive philosophy applies perfectly to the geometry side of things, particularly in an activity the source materials call the shape detective. Instead of passively staring at isolated shapes on a flat piece of paper, kids become active investigators. They start their mission by scanning the room to track down all the circles, maybe a shiny doorknob or a button on a coat. Then they shift their focus, moving on to hunt down squares, like a floor tile or a wooden picture frame. Finally, they set out to locate the elusive triangles. It's a remarkably simple sequence of tasks, yet it totally reframes how a child interacts with their spatial environment. They are constantly sorting, categorizing, and actively hunting for geometry. It empowers them to take ownership of their learning, quite literally turning every single room they enter into a living, breathing mathematics laboratory.
Which brings us to our final thought. Think back to those sharp corners of your desk, or that grid on your calendar that we noticed earlier. Knowing that math is truly everywhere, from the numbers tallied at a noisy play restaurant to the simple shapes of our food and our street signs, how will you apply the world of math to a young mind today? How can you use these structured visual ideas to spark that inherent, unstoppable curiosity in the children in your own life? Keep an eye out for those everyday learning moments, let them lead the exploration. And I'll catch you in the next explainer.